Hello and welcome. Oh. Yeah. Welcome to the special spooky spectacular. So today we're going to talk about 3D rendering. It's a little bit spookier today. Alas, poor Yorick. I knew him well. You done? All right, so today we're going to get multiple objects on the screen. How can we do that? Well, everything's pretty fixed, right? Thing is, we've got something called a push constant. Now, a push constant is like a direct main line into the shader. We can pass in about one four-dimensional matrix, which is all we need. Let's jump in and have a go at it.
Okay, take two. So here we are with the code. As you can see, we create new objects just as simply as creating them here and throwing them in this vector of statue pointers. Now we could just as easily load it from a file. It works just fine. And if we run this right now, we can see that it draws the same object at whatever position and rotation we want. We can play around with this and create as many as we want. So I'll go through this a little bit. There's a few bits of refactoring that I've done. The code is available. Check the description. You can jump in there and see what I've done, but it should be pretty readable. To start with, we have a main, which creates an app object and sets it up. The app object has graphics engine and something called a scene. Now what a scene does is it describes the objects. And the way it describes the objects is we have a basic statue object. It just holds two data fields, the position and the Eulers. And the scene object, if I can find this, has a vector of pointers to those statues, and it's as simple as that. Now the question is, how does the engine draw these? So remember before, when we were setting things up with the uniform buffer object, it was kind of prohibitive. Like we could only have one per draw pretty much, and in a past video I got around that by creating a whole bunch of uniform buffer objects, but that is a bit wasteful. So if we want to pass data dynamically into a shader through like a uniform or something, there's something called a push constant. It is what it says. It's for pushing constants into a shader immediately. So let me go to the shader code. It's pretty similar to what we had before. The new bit here is this constants uniform. A push constant, pretty much you can push in like a small amount of data, pretty much like a 4x4 matrix and maybe a few parameters, and that's it, which it works just fine here. So again, our uniform buffer object is now only the view and the projection. And as you can see, we're using the view and the projection here, and then we're taking the model from the push constants. Okay, fair enough. So how do we set this up? Well, we'll go to the engine and look at the structures. So first of all, in our uniform buffer object, we can get rid of the model matrix. Then we've made a push constants, which all it does is stores that one model. Okay, fair enough. By the way, down here, I've simplified the code a little bit, made it a bit more readable. And I did that with this pragma. We can define pragma region at the top and pragma end region at the bottom. And then this is what is called region folding. So we can just get that together. Okay, so there's a few things to check. If we go to the drawing code to start with, Now, in previous versions, what I did is we had a bunch of command buffers, and the command buffer stored the set of drawing commands. And we had 3 frames, so we'd have about 3 command buffers. They would be pre-recorded, and then we'd work with that. In Vulkan, it's actually a lot more common to have your drawing commands as like a single submit command buffer, and to re-record that every frame. It's not a big deal to re-record it every frame. The majority of the work is actually done in the submission, and that doesn't matter if it's pre-recorded or not. Okay, so we'll go through this code. So we do the usual work of acquiring an image. Now we'll begin single time commands. This CMD is the drawing command buffer, which we will use in this frame. So we begin the render pass, and actually what I did is I got rid of the create command buffer function, and I just put this code in here. Okay, so we're setting this up with our render pass info and our clear values. Again, this is just copy pasted from create command buffers. Okay, that's great. We pass in the clear values. All right. Now another thing, remember, which must be done is if we go to create command pool, we need to set a flag. Can I see it? Oh. Maybe we don't need to. Okay, never mind. Never mind. Okay, I must be thinking of something else. So that's right. If we have a command buffer and we're going to re-record it, then there's a flag that we pass in to reset the. Maybe I'm going crazy. There's definitely a flag we can pass in to reset the command buffer. I guess we're not doing that here. As always, like if you've watched all my other videos, you should be confident enough to grab my code and dive in. The reason I'm not going through this is it would just take a long time. Okay, so we begin the render pass and bind the graphics pipeline. By the way, if we had a bunch of different shaders, each shader would need its own pipeline, and that's where this would come in handy. I would do like one pass with one type of pipeline, then I'd bind another one and continue. Same thing with these objects. So if I had a number of different, vertex buffers and things that I wanted to bind, I would bind them all and set different offsets. I may do that in a future video. I probably should do that, right? So we bind the descriptor sets, and we go and do the work of drawing the statues. So we'll have one statue object in video memory, and we'll draw it at a bunch of different positions and angles. So I've just done this as underscore on the end because I made the brilliant decision to store statue down here as the mesh object as well as the mesh description. It's fine. So what we do is we set up the model transformation just like we would in any other program, and then we initialize the push constant, and then it's this command here, command push constants. So that takes the command buffer that we're working on, the layout of the pipeline that we're working on, the stage that we pass it in. This is coming in at the vertex buffer. I believe that's offset. Let me just double check. Yep, that's the offset. No offset. The size, it is what it is. Okay, then we go ahead and draw it, and it just works. It's very cool. Okay, then the rest of this is pretty normal. We end the render pass, we submit it, end the command buffer and everything, and then what I did here down the bottom is we need to free the command buffer because unlike before we were working with pre-recorded command buffers, we need to free it every time because we're allocating it every time. And then I was also a little bit lazy and I called queue wait idle, which is the reason that the frame rate dropped from like 8,000 frames per second to 3,000 frames per second. It's fine. 3,000 frames per second is perfectly acceptable. Okay, so that's all well and good. There's just one more thing that we need to do, and that is we need to set up our pipeline to accept push constants. So here, create graphics pipeline. It is all well and good. A lot of code. And then down here, so in the pipeline layout information, we specified that we are using push constants. So we create a push constant range, like a range of data that we're pushing in. We set all of this stuff, should be pretty self-explanatory, and then we pass it in. And that's it. So this is handling multiple objects the correct way. Cool. As always, code is in the description. And yeah, see you next time. Have fun. That's cool. That's a good feeling.
Well, that was pretty cool. We got things running. See me in the next video where we do something else.